In this video, I want to talk about how you identify significant digits and how you calculate with them in science class. Significant digits, which are also called significant figures, or sometimes even abbreviated as sig figs, they're necessary for accurate scientific measurements because they take into account the digits, the numbers you are certain of in your measurement, plus one more uncertain or estimated digit. The certain digits are ones that we have lines for on whatever measuring device that we're using, whether that is a metric ruler or a graduated cylinder. The certain digits have actual lines there, and then the uncertain digits are what we estimate between the lines. Different measuring devices have different amounts of lines with certain digits on it. So we have three different rulers here with three different degrees of certainty or degrees of precision with how they have been divided into smaller and smaller units. This first ruler is not particularly precise. We've got a digit over here, a 1 with a measurement line, and we want to know how large is this arrow. Well, we're going to have to estimate really all of our digits here. So you would, eyeball it and say, okay, that's about half, and that's about a fourth. So it's probably less than a fourth. So maybe, it's a 0.2 or a 0.1. It's somewhere in that amount. We only can estimate one digit. So you couldn't say it was 0.1794. No, only estimate one digit. But we haven't even made it to our first measurement line. Our second ruler here is a little bit more precise. We've got a few more lines on here, so we know that the end of our arrow is going to be somewhere between 6 and 7. We're certain about the 6, but we're not quite sure what comes after that. And again, it's going to be estimated. There's about halfway, so it's a little bit more than half. So let's say it's 6.6, whatever this unit is on this ruler. And then in our third example here, it is a lot more precise because we've got lines not only on the major numbers, the 10, 20, 30, 40, but you see we also have individual ones down below marked off, so you can have a line for 41 or 42 or 43. And looking very carefully at the end of this arrow, we see that it is past the 43 line, but probably not all the way to the 44. So we would estimate this as being 43 point something, 43.5, 43.6. That estimated digit is going to differ between one person reading the ruler and somebody else reading the ruler because it is an estimated digit. On this example, the ruler, we've got measurements again where we're using the measurement lines where you've got very precise measurements. We have a line for 18 and we have it divided between 18 and 19 in tenths, and so we can say that we're certain about 18.7 and then estimate even to the hundredths place to 18.73. So when you're estimating the number of digits you have, the number of positions maybe past the decimal point, all depends on how the measurement device is divided up, what certain lines you have, what certain digits you have already present on that measurement device. So when a measurement is provided, you have a few rules to follow to count the significant digits. And the significant digits then are what you're going to use in calculations. So all non-zero numbers are significant. If it's not zero, it's significant. That's really easy. It's when you get to zeros where it gets complicated. The first thing you need to know about zeros is that zeros that are in between non-zero numbers are significant. And zeros at the end, otherwise known as trailing zeros, when there's a decimal point, are also significant. So if we look at those three rules for examples, all non-zero numbers are significant. 237 has 3 digits in it. None of them are zero, so there are 3 significant digits in that number. The zeros in between non-zeros are significant. So in 39,004, we've got 5 significant digits. And really significant digits are telling you that this measurement device is so precise that we could even get the ones place on this measurement. We're counting 39,004 of something, not 39,000 and estimating how many more there are, but we are very precise. And then again, a zero in between when you have a decimal point or not is significant. So we have 3 significant digits. And then our last ones, ending zeros or trailing zeros. When there is a decimal point, you do count them. So 620.0, that point 0 is important because in your measuring device, that tells you you're right precisely on the line, not a little bit beyond it. And so it is a significant digit. And then sometimes you even get a decimal point at the end of a number without a zero following it, saying that again, this ones place is 19,000. That ones place, we are certain of it. It is not 19,000, maybe one, maybe two, maybe 18,999. No, that zero there, we are certain of that measurement, and the decimal point at the end just tells us that that zero is absolutely precise and we can count on it. But there are zeros in a measurement that are not significant, and this is where it gets complicated sometimes. Leading zeros, zeros that are in front of a number, are not significant. And ending zeros, if there is not a decimal point, are not significant. So this first example, leading 0.008, those two zeros in the front are placeholders. They tell us that the 8 is 8 thousandths, but the zeros themselves are not counted. So there's only one significant digit in that measurement. And then this last example, 140, where we have an ending zero but no decimal point, we only have two significant digits because this last zero is an estimated digit. So maybe the measurement was 141 or 142. We're not quite sure about the precision of the last digit. Again, the zero is a placeholder. It's important to let us know that we're certain on a hundredths and a tens place, but we're not certain on the ones. So now that you can identify significant digits, how do you calculate them in science class? Well, scientific calculations, in order to be trustworthy, must have the correct number of significant digits in the final answer. The way you do that is to first do your math calculations, then count the significant digits involved in the calculations, and follow the rules to determine how many digits are needed in the final answer. To get to that final answer, you round those digits off correctly. When you're adding or subtracting, then, the rule is to count the decimal places of the numbers that you're working with, and your answer matches whatever measurement had the fewest decimal places in that equation. So if we look at these two examples here we're adding a fairly large number with 4 decimal places to a number with only 2 decimal places, and so the correct answer is only allowed 2 decimal places. Since most of us will be using calculators for these kind of measurements, you know you can get calculators that'll give you 8 or 9 digits on there, but they're not significant. They are measuring to a smaller degree. I mean, they're measuring mathematically. We really couldn't measure anything to that degree of precision when you're in the tens or hundreds of thousandths of places. So significant digits are a way of making your measurement realistic to what you actually have as a precision in your measuring device. The second example, we have 1400, where again there's only 2 significant digits here and 1 significant digit or 2 significant digits with a decimal point in your second number in this math problem. And so the answer, we're looking just at decimal places when you're adding and subtracting, so your answer would have no decimal places because there were no decimal places in the one number involved in the equation. When it comes to multiplying and dividing, which you probably will be doing much more often than adding or subtracting, again, you're counting significant digits, and the answer matches the measurement with the fewest significant digits. And so for our multiplication example here, we have 3 significant digits, no zeros in there, so it's easy to tell, multiplied by something with 4 significant digits, and so the answer would be expressed in 3 significant digits. Same thing with dividing. We have 3 significant digits on the numerator here, only 2 significant digits on the denominator, and so our answer is in 2 significant digits. So you count decimal places for adding and subtracting and significant digits for multiplying and dividing. And in both cases, you just use the lowest number when you're putting your answer together. When you're done with the calculations, you have to round off to this proper number of significant digits. And it's important to wait until you're done with all the calculations for a more precise answer. So if you have numbers that have 4 or 5 significant digits, you can go ahead and use them in the calculation. And with our calculators, it's very easy to use those big numbers. but then do the rounding off at the end. So you've done rounding off for years in math class, and you follow the standard rules on whether you round up or round down, depending upon what the number is next to the place value where you're going to round to, except for 5. In science, 5 is treated differently. If we always rounded up when there was a 5, in science we would always be tending to be a little bit too high. And so in order to kind of even off how many times we round up with 5 or rounding down with 5, the rule is that in science, when you are rounding off and the number, the digit you are looking at to determine how you're going to round the one that's right next to it, is that 5 is going to keep or make it an even number. So 5 keeps it or makes it even. So just give you a couple of examples. Here I have some answers that I need to round to 3 significant digits because that's all I'm allowed in my answer. And so if I start with 1,364, I have 4 significant digits. I'm only allowed 3. I'm going to round down and take this last place. In fact, I'm going to take it all the way down to a 0 so that I'm left with 3 significant digits, the 1 and the 3 and the 6, because that last 0 without a decimal point is not significant. Here I have 106.7, and I'm being asked to round up because I need 3 significant digits, and the 0 in between the 1 and the 6 will count. So the 7 is going to turn the 6 into a 7, and 107 will be the answer. In this particular problem, we have 0.02335, so there's 4 significant digits for starters. All of the non-zero numbers are significant. Our 5 is going to affect the 3. How are we going to round it? We're going to round that 3 up to make it an even number, so it'll become 0.0234. And last we have 4.065, again rounding to 3 significant digits. At 0 in the middle will be counted, so we need to decide what happens to this 6. Well, the 5 doesn't affect it because it's already even, and so it stays, it becomes, or just you just drop the 5 and it's 4.06. So you need to use these rules when you're calculating in class. These are the scientific way of approaching math, where you're thinking about significant digits and using the proper techniques for calculating with them.